All right. Hello. Good evening, everybody. Well, good evening for me in North America here. But if you have anybody in Asia or Australia, it might be like bright and early in the morning for you. So welcome to the April CTCFT. As always, we're going to be following the Rust Code of Conduct throughout this meeting. We have several of the moderators here in the chat today, but you can also reach out to us afterwards, either on Zulip or I should have put the CTCFT email here, but it's just ctcft@rustlang.org or rust-lang.org. And so throughout today's meeting, you do have the ability to turn on your camera, but we'll just ask that while you're not asking questions, you keep yourself muted, you keep your camera turned off. And if you're going to be asking questions and you're not comfortable with video or with talking, feel free to ask them in the chat, and I'll be more than happy to relay them to our speakers today. And so as with the last few months, we've been working to get more suggestions from the community on what talks we'll be doing over the next few months. And so this is not only just for like the talk subjects themselves, but also the themes of each meetup. And so for this meetup, we will be doing, or the theme for April is learning. And so we have some pretty great speakers here who are both working on separate initiatives, and we'll hear a little bit from them about some of the stuff that they've been doing and what they've learned. But we don't have a theme for May just yet. We do have some ideas, and we'll be discussing it as a CTCFT team, but we're always open for people suggesting themes. And so feel free to either suggest a talk if you know something that's interesting that's happening in the Rust world or within some Rust teams, suggest a theme for future months. And yeah, you can do that at the CTCFT repo. And so to get us started today, we're going to be having John Ho, who is going to be talking to us about teaching intermediate Rust. And so John, I will pass the torch over to you. I'll stop sharing here and let you get going.
Amazing. Let's see if we can get technology to work here. Let's see if I can share my screen. I will try my best. Can you see the slide?
Looks good. Yes, perfect.
And because I'm using a tiling window manager, it jumps around a bit, and there it should be stable now.
So it looks good, but at the top we have some interesting bars and stuff like that.
You have some interesting bars.
Yeah. Now it might not be too much of an issue if the content is in the middle, but it looked better when it was like in the thinner version.
Interesting. Is that better?
This is good. Yes.
All right. Let's use that instead. That's fine.
All right.
Okay. Hi, everyone. My name is John, and I want to do this by first just like, who am I, just in case you don't know. I wrote Rust for Rustaceans, which is a book that's intended to follow the Rust book. It's sort of intended to be sort of, you've learned the basics. Now let me teach you more about the more intermediate aspects of the language. I do live Rust programming on YouTube, and I maintain the Rust build tooling at AWS. I'm giving this talk because, and I'll get back to what the talk is actually about in a second, because I've been trying to teach intermediate Rust for years, but both through writing that book, through the videos, and also internally at Amazon, but also internally at MIT around the research group I was working on there. A lot of that was just like trying to get people on board with Rust, helping them when they get stuck. And so I've fielded a lot of questions from Rust developers, both new and experienced, over time. And this has left me in a position where I've seen a lot of the things that trip people up, and I see the things that keep tripping people up as they try to graduate further into the language. And so that brings me to today's talk. The talk I'm giving is on why is Rust still hard to teach? And I don't mean that in terms of the language itself. Like, there are obviously things that are complicated and that are hard to teach in that way. But what are things that we can make better? What are things where there's unnecessary friction to the teaching aspect of things? And I think it's going to be easier to see what I mean by that as we go through the talk. So I just want to start going, and I'm going to be touching on a lot of different topics here. And because we only have 20 minutes, I'm going to go relatively quickly through it. And then hopefully at the end, and also in the social hour, I'm happy to talk more in depth about these as we go. The first of these is, and this comes up a lot, is where do I look things up and where do I ask questions? And this pans everything from beginners to extremely advanced Rust developers. This problem just keeps coming up, and it's not that weird, because if you look at it, there are so many resources and the list keeps growing, right? I've listed some of them here. I'm not going to go through all of them. There are plenty more than what's on here, and many of these link to many of the others, and you end up with this huge array of resources. And a lot of people just end up either getting lost in this and not being able to find their answer, or they sort of give up early and actually end up like emailing or DMing me. And I'm sure this happens to a lot of other people in the Rust project whose names or email addresses are out there. And it's not that I mind the DMs, it's that it suggests a deeper problem with how people learn, how people pick up the language, how they explore the ecosystem. And it's great that we have all these avenues, that we have all these resources different people have developed. The problem is that it's very hard to navigate and it's very hard to discover what resources are out there. So we end up with people repeating questions, repeating, these longer explanations of how something works. We end up with repeated books or repeated content, and that's unfortunate. There are some resources that try to organize this information, right? We have the Book of Rust books, we have the Rust Learning repo, we have the Awesome Rust repo, we have the Awesome Rust Mentors repo for mentors, but those are themselves hard to find. Like, how would you know to look for these if you didn't know that they existed already? And all of them suffer from this giant list problem of they list a bunch of other resources that then have lists of table of contents or of other resources. And it just becomes this feeling seemingly endless supply of resources where no one really knows where to go if you just have a question. And the question is, can we do better? I'm not proposing here that we just like have one resource that is everything, but can we find some way to organize this information to make it easier for people to get to the place that explains the thing they're looking for faster? And then to switch categories completely, the other thing that I see come up a lot is that paper cuts tend to inhibit learning. What do I mean by that? Well, the Rust language has a lot of known shortcomings, and they're not that bad if you know that that's what they are. If you're an experienced developer and you know that there's this particular bug in the borrow checker or in the trait system, or this feature hasn't been implemented or whatnot, then when you come across them, you can just sort of file it away to, oh, right, I need to do an if let here because the match doesn't work or something like it. But they're extremely confusing if you don't know that these are known shortcomings, because they suggest that your mental model is wrong when it isn't. And that's what makes people give up. If you encounter a case where you look at your code and you think really hard about like the Rust mental model and what the borrow checker is supposed to be and the lifetimes, and you're like, this is right, and the borrow checker keeps telling you you're wrong, or the compiler keeps giving you an error, that is extremely frustrating. And it's something that I think we should work really hard on fixing. And I know we are already, but I think it's valuable to prioritize these kinds of fixes. To give some concrete examples, here are some tickets that keep coming up for me. One is there's an issue where closure arguments need to be specified or the code won't compile. There are cases, there are known problems even with NLL on borrows and early returns. There's some confusion between function f and def items and function pointer types, which are different types in Rust, and there's no automatic coercion between them. Arguably, also things like trait aliases, GAT and type alias infiltrate are also things where newcomers or experienced developers will try something and it just won't work, even though it sort of seems like it should. It seems like a natural part of the language, and you just get an error. And I think that causes people to get stuck when they shouldn't need to be. Another thing that I see a lot is that choices are hard in Rust. And I don't think this is a Rust only problem, right? This is arguably a fundamental problem that sometimes there are just multiple options and you need to be able to pick between them. But it is a major stumbling block. And we see this all throughout the Rust ecosystem, both in the standard library and in the ecosystem more broadly, right? Do I use RC or do I use ARC? Do I use mutex or refcell or cell? Do I use usize or isize or non-zero types or whatever? Tokyo async std is a classic one. All of the different error handling libraries, all of the different command line parsing libraries, or you have the ones where there aren't any clear alternatives, right? Like regex and rand. There are some that are sort of starting to creep through, but realistically, these are the ones you will use. And again, choices here is good, right? It is valuable to have this wide array of possibilities that can explore and develop independently, but it is really hard for users who are just trying to figure out what to do. And I wonder here whether, like here, we can to some extent fix the problem with documentation that explicitly shows differences, right? Tables that have, crates down one list and features over the other, and there's like checks marks and X's. That kind of stuff helps, but it only helps to an extent because it relies on a sort of faithful evaluation of the other products. But it also is hard to maintain over time and keep up to date. It's hard to write in the first place. It requires a lot of work. And it's not clear that they're like standardized. Very few people actually do this, very few projects. And so the question is, can we encourage that somehow to make these kinds of choices easier? Like in the standard library, can we make sure that every place where there's a choice, we can document what the inputs to that choice should be in order to make a rational, reasonable decision that also works longer term and not just in the moment. Basically, how do we teach how to choose? I think is something that is a problem in computer science more broadly, but hits Rust really hard, especially in these early days, where for many of these there aren't established answers. I see cargo as a growing concern. Basically, as Rust itself becomes better, as Rust's diagnostics become better, as Rust's the resources for us become better, cargo, it's clearer and clearer how far behind cargo has fallen. And sometimes this is due to known limitations. Sometimes it's due to poor diagnostics, poor errors. Often it's simply due to lack of knowledge, just that users just don't know what cargo can do. And it's sort of a mix of all of these. But basically, no one reads the cargo book. The cargo book is pretty good, but it's a very long book about something where chances are you only really need a small part of it. It's really more like a reference. And few people even know that it exists. And this is unfortunate because there's a lot of good stuff in there. But it means that people think cargo can't do something or don't even realize what it can do. Some examples of this are feature merging. So this is the point that cargo merges the features of all places where a dependency appears in your dependency graph, which is one of the reasons why you can't have mutually exclusive features in cargo. Build scripts are very hard to understand for people who haven't really dug into them. But even if you feel like you understand them, it's not clear what the right answers are, whether you should use things like CC or package config to emit all the right cargo magical standard output things. If you have a native dependency, should you use git submodule? Should you vendor? What are the right patterns here? And this is something that I think we don't even have good documentation for in the cargo book. How should you do inter-workspace dependencies? Should you specify path or version or path and version? What should you do on a release? Not entirely clear. The fact that you should probably specify dependencies with default features equals false if you're a library, that kind of stuff is not really taught anywhere. Same things like foot guns around, how Rust flangs are and aren't propagated in different parts of cargo, especially around cross compilation. And it doesn't have to be these. My point is more, there are a lot of rough edges to cargo. And as Rust becomes more pleasant to deal with, those pain points in cargo become even more visible to users as they develop into Rust. And I think diagnostics could help with many of these. Both, errors in cargo could get better, but I want Clippy for cargo. I want to run Clippy on my project and have it tell me things about my cargo.toml that maybe I should be doing differently, or my build.rs. Unsafe remains unclear. this is something that I think is relatively well known, but basically everyone is either too scared or not scared enough about unsafe. And there are some people in between. This is a little bit extreme, but in general, the problem we have with unsafe is that there's just constantly changing ground. We saw this recently with strict provenance, which is a great idea, but it means that we don't know what the right mental model for unsafe is. We don't know what the right semantic model for unsafe is. The rules are under or entirely undocumented. The Unsafe Code Guidelines Working Group, it was great for trying to document the really fundamental assumptions that Rust had around unsafe code, but progress has been really slow, and that's unfortunate because it means that even if you really try to understand unsafe, you sort of hit a wall where there aren't answers deeper down, or you need to track down the right person to ask. And that means that it's really hard to pick things up on your own. It's really hard to, there aren't a resource you can go to learn how it really works. The Nomicon is the closest we have, and even that's not really fully kept up to date over time. Established conventions might help a little bit here, right? Things like mandating safety comments, both on declaring and on use. I think it'd be really cool if you could formalize this as part of the language, and you could name different, this is a safety invariant that I require. This is a safety invariant that I'm signing off on having done, and have that checked by the compiler somehow. But it doesn't really matter. What matters is currently it's painful because it's hard to know what the rules are, and there's very little enforcement of those rules. It's really unsafe or not unsafe, and I don't think it has to be quite that binary. MIRI is great, but the analysis there is kind of limited, right? Especially if you don't use any of the -c flags. It only checks the test that you wrote. It doesn't, just check all your code. It's not static analysis. And the fact that it's nightly only is a little bit of a problem. It means that in cases especially at larger organizations where you can't use nightly, you just don't have access to MIRI. And that's something I think we should work on improving. And I think a sort of corollary to this is we should work really hard to stabilize unsafe removing functions, right? One example that came up for me recently was the ability to take an array of some length and turn it into an array of mutable reference to each item. This one there's an unstable feature that adds this, and that works just fine. But without that feature, there's a lot of really hairy unsafe code that I have to write myself to make that work in the meantime. I think we need to have some forward momentum on trying to stabilize these things. And I know there is some already, but I think there's sort of outsized value in trying to stabilize things that allow users to not have to write unsafe. And if you thought I've gone quickly so far, I'm going to do a quick fire round at the end here of just single slide things that I've also observed. And I think I have the time for that, so I'll be quick. The first is that I think the Rust survey should ask what's hard. We need data for this kind of stuff. We should ask what users do not understand or what they later realize that they misunderstood. Because the teaching resources currently are just sort of me and other educators just sort of going, I think this is hard, I should do something on it. Having data here would be super valuable. I think what is a breaking change is a question that comes up a lot in the community, and usually because people didn't realize something was a breaking change and then it breaks someone. We need central documentation for this. There's a bunch of RFCs that collectively describe this, but we need something better. We also don't really have, one particular pain point here is dependencies that leak into your public set of dependencies, your public API, and therefore breaking changes to them or breaking changes to you, even though you didn't really intend for that to be the case. I want more documentation to explain why. I found that developers don't believe necessity claims. Like if someone just says, send and sync saves you in a lot of cases, it's just good, or, static is necessary here, that they have to the docs need to start to show why it matters. Give concrete counterexamples in the docs for what goes wrong if this bound wasn't here. That's how we teach people, that's how we make them remember why these things are important and what they do. Also, as a separate point here, does anyone actually read -- explain or run it and then read the text that comes out? Because I know I very rarely do, because it's extra steps. Is there some way we can repeat these in docs so they become more visible and more people read them? Because there's a lot of valuable content in there. Procedural macro docs are really lacking. We need end-to-end examples, and there are very few of these. There's the great David Tolnay workshop, and there are like some examples here and there, but we really need something more thorough and ideally in the standard library docs. I want ecosystem-wide search. I want the ability to search for a method or a method signature throughout the crates.io ecosystem and the standard library. These things exist for R, and they really help with discoverability when users are just like looking for a thing. I want, for understanding slow builds, this comes up a lot too, where developers don't really know how their build works. And the stabilization of --timies is great, but it's incomplete, right? There's a bunch more stuff here where we could do better, like showing which proc macros are actually causing the delays, where time is spent linking, that kind of stuff. And finally, a way to track unstable features and what's blocking them. I think this comes up where users are really waiting for some unstable feature to land because they want to get rid of Unsafe, for example, but there's nothing that tells them what's currently blocking that feature. And I think that causes frustration for users as well. So in conclusion, I think our resources need organizing, our paper cuts need fixing, our choices need better comparisons, cargo needs love, and Unsafe needs rules. And I think that's all I have time for, so I'm going to stop there. But thanks for listening.
Great. Thank you so much, John. And so we'll open up the floor to questions. I think we do have about 5 minutes here. And so if you're interested in asking a question, either feel free to ask in the chat, or you can raise your hand in the chat and speak up. Nico, I noticed you unmuted yourself there.
I have a question. First of all, thank you. That was an excellent talk and lots of good stuff. I'm going to have to rewatch the recording, but I had a specific question. One thing I noticed, you mentioned counterexamples. Something that's been on my mind, and I'm curious to get your read on it, is what if we could try to frame like all the borrow checker errors as, here's a concrete counterexample. Either here's code that actually goes wrong, like here's how your code is broken, or if it's not quite broken now, but it could be broken by a small change, here's something this function that you're calling could do that would mess up your code. Do you think people would respond well to that?
I think that would be fantastic. At least what I've seen so far is that for my streams in particular, that comes up a lot, where if I just try to use words to explain why, I need this bound here or something, it helps a little maybe, but when it really starts to like stick for people is when I show, here's where this goes wrong. Like I write code that they can read and see is wrong. It helps a lot. And it helps you retain that knowledge over time too, because you remember that, oh, this could break in that way. And then you start being able to apply it to other situations. So yeah, I think that would be great.
Yes, Will, feel free.
I have a question. Oh, thank you. So yeah, fabulous talk. Very deeply interesting problem to me. I'm curious just what, on the topic of organizing resources, what kinds of organization do you think would be most effective for helping match, I guess, the individual resources with people's problems? Because I guess I'll say from my perspective, having thought about this a little bit on things like, how do you find a relevant method in a giant docs RS page, for instance? Like I don't think we really have a model of like what kinds of questions developers are asking, right? Because there's a very different kind of question to say, like, what is a vector in Rust versus what is the equivalent of append in Python in Rust versus like, what's the difference between using a vector and a hash set versus right? Like, I think there's one perspective is we need to have a better taxonomy of the kinds of questions that people have. And then that taxonomy becomes the basis on which you then organize these materials. So I have some thoughts about that. And so I'm curious if you think like, A, that's a sort of valuable direction, or B, if there are other like axes along which you think these things should be more organized than they already are.
I think we need to figure out some user stories basically here, right? Like what kind of people or what kind of situations are developers in where they currently are not served well by what we do, right? And I think there are a couple that come to mind. The first is I want to do this thing and I don't want to write the code for it myself, right? Like this is the, how do I find hash map? Now for hash map, that's not a problem. It's in the standard library. That's where people search first. But, you know, if I want to find a library to do X11 window management, right? What do? I go to crates.io, I search for X11, and then I like sort by recent downloads. It's not a great experience and very hard to actually find good results. And for that kind of, I'm just looking for a thing that solves problems in this space. I think we could do a lot better, even just by, you know, categorizing the crates that we have. Crates.io does do some categorization, but I think it's a space where we could do a lot better. The second one is, I'm already using this library and I want to figure out how to do this thing. And that one I think comes more down to, you know, I'm looking for a method signature that's kind of like this. People don't generally think in terms of method signatures. I don't think, I sometimes do, but for me at least, the way I solve this problem currently is I go to docs.rs, I open the type that I have, I minimize all of the documentation, so it's just a list of function names, and then I read the list of function names. And that's also not a great way to find things. It would be nice if it was better. And then I think the third one, and this is maybe the one you're getting at with the taxonomy question or point rather, which is, you know, I want to learn about how this thing works in Rust, or how to do this thing in Rust. And here too, we have a lot of resources, right? We have Rust by example, we have the Rust patterns book, we have the Rust cookbook, we have, there's one more that I forget now. We also have Cheats.rs, which arguably falls in the same category. And they're all trying to get at the same problem in slightly different ways. I don't have a great answer for how those should be organized. What I really want, right, is like, I want to just type my search and have it give me the right answer, which Google works pretty well for Rust resources, right? I could type Rust and then sort of type my question, and I might get some of the good ones. But I think here we're sort of searching for a log-n solution, right? Where rather than having to search through all the resources, I can like walk a tree or something, and every time I get slightly closer. But ultimately, I think we need to categorize what are the underserved use cases. That's where we need to start. I don't know if that answers your question quite, but
yeah, no, it does. It's a very, very satisfactory answer. I will say, I think another interesting set of resources that would be worth categorizing is blog posts. So for those who are interested, there was a Rust subreddit post today that was called "What was your path for learning Rust?" And it was pretty interesting. There was a lot of comments. The prevailing comments were like, I read the Rust book and then I started a hobby project. But like the top comment was, I read the book, I started a project, and then I read the Rust subreddit every day for 3 years, which I think is very indicative of like, you're in the thick of all of the great content that people are producing, and you catch it when it, you know, zips by your feed, right? But then for everybody else who either they didn't stumble across it organically, nor do they have the keyword terms to fetch it, they then miss it unless it's collated in one of these awesome lists. And so thinking about ways in which, you know, that really high quality content that a lot of Rust folks have written, but it's now just like gone to the ether, bringing that back, I think could be quite valuable.
Yeah, I think Rust currently has very little institutional knowledge, and it's a problem. Or rather, it has a lot of institutional knowledge that's not written down anywhere, right? So these are all of the great blog posts that have been written, all of the great discussions that have happened, you know, on users.rustlang, or just in Zulip, or in Discord, where it just gets lost, because if you weren't there at the time, you're not going to find it again. This is a problem that I think applies to a lot of languages, and we don't have an obvious answer. But for me, an example of this is there's some really good blog posts like a couple of years back on zero size types that I still go back and read every now and again, and they're fantastic. But if you tried to find them now, you wouldn't even know that they existed. And I don't know how to solve that problem, but it is a problem.
I'm just taking a look at some of the chat questions here, or just like some of the comments. And one comment points out that it would be nice to have a place that you can go and find paper cuts more easily.
Yeah, like a list, basically errata, like a list of known problems. So one thing that I think Go does really well is the standard library in particular, but also libraries more generally, can put like in their doc string, they can put like bug as a section or as a list header or something. And those all get listed in the output documentation as known bugs about this implementation. I wonder if we could do something similar for even just for diagnostics, right? Like if this is, I'm like mentally pinging Esteban, which is, if my code doesn't compile for a reason that's a known shortcoming in the language, can you please link me to the tracking issue or the issue for that bug? That'd be fantastic. That's one way to, let people know that this is a known problem.
Mm-hmm. Yeah, so I think there's some other stuff in the chat that you can take a look at afterwards, but I think we'll move on here. So thank you so much, John, for answering these questions. It's really, I think, great to have these interactions. So thank you very much.
No, thanks for having me.
Absolutely. Nico, I will hand it over to you for phase 2 of the Rust Reading Club.
Yeah, so this was supposed to be Doc Jones, but I don't know. I don't see her, so I'm just gonna pinch hit. Which is too bad because all the good ideas that or at least what I think are good ideas that I'm about to talk about are all really hers. So I want to make sure she gets the credit. But let's pull it up. Okay, let me share the screen. Okay, can you all see it? I assume.
Yep.
Cool. So, as I mentioned, I'm not in fact Doc Jones. I'm Nico Matsakis, but I wanted to talk about some of our experiences and that Doc Jones and I had running this Rust-C reading club, and some of the things where we think would be cool to do next. And you can kind of get a hint from the title where this is going, the Rust contributor program. But so what was this Rust-C reading club? If you didn't hear about it, well, the idea was we thought we saw these code reading clubs that are all the rage, by which I mean there are a few of them, where people kind of get on Zoom and read code. That's about it. There's different variations. But the idea is to kind of get practiced at learning to read code, since actually it's something we rarely train you for, but you spend most of your life as a coder doing. And so we thought it'd be cool to just sit and read the Rust-C sources. And there's parts of Rust-C. So I've been working on the compiler for 10 plus years, and there's plenty of parts that I don't really understand. And I assume that's true of others too. So we thought it might be a good way, get some people who have, the original idea was, let's just get a bunch of people together and read the source and ask questions and talk about it. And some people will have deeper knowledge and some will have no knowledge, and that'll be kind of useful because first of all, the people with no knowledge will see that the people with deeper knowledge actually also have huge gaps in their understanding. And in hearing the questions and thoughts of people with less knowledge, that usually helps sometimes uncover surprising insights, actually, because you're kind of coming with fresh eyes. So that was the idea. It did not work quite as we hoped. The mixing of skill levels was more confusing than helpful. And we stumbled as we went on some really cool ways to work through, like reading code by itself, especially for some of the more complex parts of the compiler, was challenging, but we started using this really neat debugging tool that I'm a big fan of called Pronosco. The idea here is you capture a trace of your execution and you can replay it. And it's sort of like a debugger, but much better because you can jump to any point in the execution and see what the exact state of the program was. And you can do things like say, oh, I'm here in the output. Let me click in the output and get taken to the state of the program when that output was generated. So if you generate a bunch of log statements, that lets you sort of find the place you're interested in and then jump right in there. And so it seemed like, oh, well, we started walking through example programs with Pronosco. So we would read the code, get an idea of what it does, then come up with an example that we think might help us understand it better, run the example. That was really cool, but there was a problem that Pronosco itself is a fairly complex tool. And, most people, if they didn't show up every week and they just hit Pronosco for the first time, they wouldn't really know how to use it and they would get stuck there. So you kind of had this learning curve that was causing problems. So overall, I'd say it was fun. It was a good success in some ways, but we had to retool it. It wasn't the the program we hoped it would be. And so that's where this slide comes in. Oh, well, okay. I guess that that's what I just talked about. There was some interesting chaos because the first time we posted it, we said we kind of just posted it far and wide, and then so many people showed up that we had to cancel because we literally couldn't start the Zoom room. So if you want to get more details of all that stuff, Doc Jones has a great post doing a retrospective. But so let me step back and say, here's what we're thinking as a refined version of the reading club. This is the future. Think of it like a user story. This is what I would like to see happen when you show up as a Rust contributor, right? So suppose you're a Gonzo and you say, I want to learn to code. I want to learn to code in Rust C, right? I want to hack on the compiler and become a compiler contributor. Today, what happens? I don't know. You go find some issues. Maybe there's some easy bugs that are, maybe you can find something to work on or find a mentor, but it's a little bit chaotic, right? It's kind of like the thing John was talking about. There's 101 resources. It's a little hard to figure out where to get involved and what the right place is. But in this future we're imagining, instead of that, there's a very clear place you can start. There's a, let's say, twice a year program called Rust Contributor New, and you can essentially apply, right? And it doesn't take as many. It takes a kind of fixed set of people. So you'll apply, and maybe you'll get selected for this program, and maybe you won't. But and then what happens then is, the reason it's a fixed set of people is because each person who's in there is going to get a bug of their very own that we're going to hold for them. There'll be a dedicated stream. So the idea is that you'll group together with other people who are trying to learn how the compiler works, and you'll form a kind of cohort, right? And you'll have a stream on Zulip where you can chat to one another, and there would be fixed times, office hours, where some members of the compiler team would be available to help you to fix those bugs, right? So the idea is these members of the compiler team will essentially find bugs and then help you learn how to fix them. And so the idea would be then that you kind of, over the course of a month or 2 months, you leave having fixed some bugs and done some work on the compiler. So at that point, well, I'm telling the story out of order. And so Gonzo hears about this program. Gonzo joins in, gets accepted, gets excited, meets the other people in his cohort, and they get to work fixing the bugs, right? And like I said, every once in a while, they hit some problems. So the nice thing is they're able to talk to one another because they have this cohort in this dedicated stream. So maybe Gonzo has a problem and he can say, hey, Miss Piggy, did you figure out how it works to add a new log statement? And Miss Piggy says, oh yeah, I know how to do that. I found a good example. This is how you do it, right? But some of the questions are harder. It's not something that they're able to figure out working together. So then they can attend the office hours where the team members are there, people who are experienced with Rust, the Rust compiler, and have a better idea how it works. And they can kind of answer questions and help get you back on track. And so finally, at the end of the program, you've kind of fixed your bug and understood how the compiler works. Maybe we play Pomp and Circumstance. Let's see, will you hear it? I don't know. It's this song. Oh yeah, well maybe you can't hear that because it was playing really loud in my headphones. But it's the one that goes da 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 da. So we play that, and you've kind of graduated. And the idea then is now you've got a basic idea of how the compiler works, right? And you're still learning, but you've fixed a bug. You know how to run the tools. You know how to get the log output. You know how Pronosco works. And so now the question is, let's say you liked it and you want to do more compiler hacking. Well, how could you do that? Well, first of all, you still got your cohort, right? So probably a lot of them, if we're successful, have enjoyed their experience too, and they're kind of hanging around. And that stream that was there for you, that stays there, and you can chat and help each other fix bugs and stuff. But then the idea is that also there would be another stream of learning events. So we talked about Rust Contributor New. This was kind of the onboarding path where you go from no experience with the compiler to some experience with the compiler. But then there would be Rust Contributor Grow. And looks like you can't see this whole slide. Let's fix that. Can you see it now? Okay. And so Rust Contributor Grow is a regular series. And this one is targeting intermediate, like actually probably a variety of levels. So every couple of months, there's another session begins. And some of them are really focused on more advanced things, like you have to be pretty familiar with the compiler to make sense of it. Some of them would be a little less advanced, right? And so maybe this month at Big Fish is explaining how the trait system works in a way that Gonzo thinks he's ready for. So Gonzo joins in on the Rust compiler Grow that's starting this month. And for the next 8 weeks, at Big Fish was essentially kind of like the Rust C reading club that we tried to do, right? Once per week, at Big Fish we'll walk through some of the walk through an example or two of the trait system, show how that code works in detail, take questions and explain it, and just kind of teach people how it works. And this happens a few times, right? So maybe Gonzo works with at Big Fish on the trait system, then Gonzo takes another kind of course on some other part of the compiler. After a while, Gonzo's landed enough PRs that he becomes a full team member and starts giving courses of his own. So this is essentially the path we'd like to see, right? Let me give it in less story form. There would basically be 2 tracks. And these numbers might not be right, but this seems maybe right. About twice per year, there would be a way for people to go from 0 to something. Of course, if any time you can come and fix a bug, that's just fine. But this would be a kind of structured onboarding for people who want something a little more set up. And the reason twice per year is basically because I think it's going to be some amount of work to organize, and I don't think we can pull it off more than twice per year. If we could, that would be great. And then also in a kind of steady stream, there would be this Rust Contributor Grow every 8 weeks, somebody from the compiler team talking about something, and more targeting intermediate levels. And I think this seems really ambitious to me, but I also think it's achievable without that much work. The idea would be that to run the Rust Contributor New program, you need about 3 compiler team members. I'm really focused on the compiler here because I love the compiler, but actually I think this applies to all parts of the Rust project. So I shouldn't say 3 compiler team members, 3 Rust project team members who would commit for about 2 months, right? The first month, I think they're just going to be finding bugs for these new contributors. That's kind of actually a hard job. So I think we'd have to have some mechanism for putting bugs on hold, because sometimes we get easy bugs and they just get fixed really fast because there aren't enough easy bugs out there, unfortunately. So maybe we can hold some and reserve them and say, don't fix this. It's not too hard to fix. Let's hold it for the Rust Contributor New program. And then in the second month, they would attend these office hours and help people, but only for fixed times, right? They can answer at any time, any question, but they only promise to be there at a certain time window. And for Rust Contributor Grow, well, that you just kind of need one person who agrees for about 2 months for 8 sessions to spend an hour a week walking through the code of some code that they know well. I think we have a pretty good idea of what that structure looks like. We mentioned this Pernosco tool and some other stuff. I mean, I think everyone could do whatever they want best, but we could also give a recommendation of like the first time you should give a lecture, the second time you should work with some of the people in the thing to find some good example programs, then walk through 2 of those programs and you're about done. That takes about 8 weeks. So that would be the idea. And then there's one last thing that's really important. So I mentioned we would need some mentors to collect bugs, hold office hours. I mentioned that somebody will have to spend some time walking through examples. I think we really need a full-time or at least employed person who is like dedicated. I guess they don't have to be employed, just dedicated. But we need somebody to organize and make sure this actually happens. Someone to kind of go and recruit people for the program, to find those 3 mentors twice a year, to line up the next couple people who have agreed to do the intermediate path every 8 weeks. And we need so that's a crucial role that I think we don't have today, and it's often pretty hard to find someone. But maybe this could be, well, I'm not sure. Maybe the foundation might be interested in that, or maybe we could find some other way. Could be a good thing for the community grant program. I'm not really sure, but I think it'd be a great role to have. And then we can use, various wonderful ways to help recognize the people who've put in this time, right? So badges, a list of mentors. I think it's, excuse me, I think it's a really cool thing to do to help grow and keep the Rust community, welcoming and healthy. So that's kind of all I wanted to say. But I think if you were going to take away something from this talk, it's that I think we should design an active education program, right? Not just kind of passive. People show up and learn how the compiler works by having the wherewithal to suffer through it, but where there's actually a structured thing that you can do to learn and understand it better. That we would have some programs targeting really inexperienced new contributors, and some programs targeting a broader spectrum of contributors, and that we would be making a commitment as a team and as a project that we're going to invest active effort in bringing new people in, right? So running these things is definitely work. Mentoring new contributors is work. Doing a talk every 8 weeks, that's work. And the idea would be that we try to make sure that that's something we all commit to and take a share in, or at least maybe not all of us. I think there are many people, there are some people who will enjoy this more than others and will be better at it than others, but that, as a team, it's something we're focused on ensuring happens. So thank you. Let me leave you with one last Muppet picture, and happy to take any questions or thoughts about it.
Great. I love all the Muppet analogies. It's a very good way to go through it. And I do want to mention for anybody who's watching along, do check out Doc Jones' blog post on this. I read it today and I got very excited from it. And Nico, one thing I was sort of wondering about is like, when it comes to the aspirants as part of like the new program, what are like the ideal type of people like in their sort of like they've been learning Rust, they've been doing some things, but who exactly would be looked for as part of the criteria?
That's a good question and something we have to figure out. I mean, I do think in terms of Rust skill, I would think you should probably have, it's probably no Rust. Like it's not really meant, I wouldn't think, as a way to learn Rust itself. But I guess there might be some people who have a lot of domain knowledge that, want to learn Rust, and that might be also okay. I think it would be a great way for us to bring in and broaden the community in terms of underrepresented groups or less well-represented groups and things like that. That's a really great conversation we should be having. What I do feel, I don't know the exact criteria, but what I do think is really important is that we do sort of limit it, that it's a small manageable size. Like it'll be better for everyone. It's too bad we can't do it for infinite participants, but the experience will be a lot better if I think it's like a manageable size where people can get to know one another and make friends and have a cohort that can support each other, than if it's just kind of open-ended but doesn't actually work for anyone. That's one thing I've heard a lot from people who are coming to work on the compiler, that it can be sort of lonely, and that they would really like to have a group of people learning together that they can ask questions of, so they don't always have to come with every question to people who know things really well.
Mm-hmm. Yeah, that's an interesting perspective. One comment in chat describes curating a list of already fixed, easier bugs, and then having, I suppose, people who are part of the new program go through and so like walk through those bugs before having them start. And so, I mean, just kind of turning this into a question, when we're looking at what the reading club's goal is as like running a reading club, why might this or might this not work as a way of like getting people together to walk through stuff?
It's a really good idea, actually. I like that idea of walking through fixed bugs. I also think it makes me wonder if, maybe, I think in the past, I had forgotten about this, but in the past, I remember having discussed with people the idea of, well, why do we have to have a bug? Like, what if we just make a bug? and fix it, right? Like you don't necessarily have to fix a bug that's in the real compiler. I guess it's somewhat less satisfying to kind of fix an artificial bug or to replay fixed bugs, but it does make sense to me that we could have an introductory course that isn't necessarily oriented at actually landing a fix to a bug, but is oriented at doing a variety of exercises that will help you get to know parts of the compiler, like different kinds of challenges. That might be better, because I do honestly feel that one of the hardest parts of this whole thing, it will be finding a set of suitable bugs. So if we can find a good way to learn how the compiler works that doesn't involve a scarce resource, that would be better.
Perfect. And Will, you have your hand up, so I'll let you speak if you like.
Yeah. So one thing I'm curious to talk about is this distinction between, say, like feature contributors versus reviewers. So, and how that relates to the program you're proposing. So in my experience, contributing to the Rust compiler, I've definitely very much been in the make feature space. Like there's a couple specific things I am interested in improving in the Rust compiler, like Rust doc or stuff related to my thesis work. And so, I implement those features, and then I get the expert help from reviewers who know way more about the compiler than I do to fill in all the edge cases that I missed. Like this was especially true in Rust doc, where there was like, oh, I forgot about themes and I need to implement stuff for dark mode, or I forgot about like XYZ features or these random use cases or whatever. And I think one reason why that's relevant is because I don't know if like people come into the project wanting to like only contribute features versus eventually become reviewers or not. And B, I think reviewing is like exceedingly important to make sure, of course, that the code meets a high quality standard, but it seems like it's not I don't know how desirable a job it is amongst many people, right? I mean, certainly I know my brother, right, was basically just full-time code reviewing for a lot of his time in Rust in the later years when he wasn't working on like crates and stuff. So I don't know if there's something relevant to that that's worth working, like thinking about in the structure of the program, about like either funneling people in one of these directions or trying to otherwise just like make sure that there will always be that reviewing base and we're not just prepping people to be feature contributors. Does that make sense?
I think it's a really good call out. I hadn't really thought about it, but I think you're right that it's really important. You're also right that, if we're not careful, we can there aren't enough reviewers as it is, always, never. And we're just, we don't want to just produce more load for the same set of people. Like, I guess my goal and hope is that by growing expertise and knowledge, we will increase the base of reviewers, but it could easily play out differently if we're not thinking about it. It does make me also wonder, I think something that I've found really useful is when people come and do a pre-review on PRs, right? Even if they're not an expert in the code, if they can kind of go through and read through the PR first and get a lot of the simple, obvious bugs fixed, and like highlight, oh, this is a really tricky part, maybe Nico can take a look at this. That can be a great time saver. And so that might be another kind of thing that could be part of this, would be like, all right, maybe that's not your first Rust contributor new assignment, maybe there's another program of like, let's work through the reviewing, and you can shadow review and help this person by first doing first round review and getting practice and used to that way that works. I don't know, it's an interesting thought.
That's a cool idea. I like that.
It's kind of like shadow interviewing in a company. John, you had your hand up. I don't know if other people do.
Yeah, I'm for the grow thing, I think one thing to keep an eye out for is if you keep telling people to give presentations, then what's going to happen is their content is going to get more advanced over time or more complicated over time because they've given it so many times before that they feel like they've covered that ground already. And so there's a question buried in here, which is, do you expect that these grow sessions will be recorded, or do you expect that they will all be sort of, curated to the individual group?
I wondered about that same thing, and I'm not sure. I do expect them to be recorded because it just seems, well, I've gone back and forth, but it just seems useful. I mean, it does make question asking a little, people sometimes get self-conscious. Some people don't like to participate in recorded streams. I did have the expectation that a lot of times the grow would be kind of retreading the same ground, and that would be okay. Like that lowers your burden as a presenter.
Yeah, I think it totally would be. I'm more like, if that is the plan, I think it's going to be, the onus is going to be on the teachers to make sure that they, actually stick to that and don't get, ahead of themselves. It's
I think,
pretty easy to do.
yeah, it's true. I guess I think in my ideal, fantasy land, there would be like prepared materials for different parts of the compiler. And it's like, yeah, I'm going to be giving the lecture on how this aspect works. And of course that's going to evolve and stuff, but well, I know a lot of things don't change that frequently. So it would
Yeah, I mean,
be worth the
it
investment.
feels a lot like basically a university lecture or course.
That's pretty much the model.
Yep.
I mean, it works.
That's true.
All right. Well, actually, one more question, Nico, that I'm sort of curious about myself from chat. What type of time commitments would we be looking at for people into different parts of the programs?
I don't have a great answer, but I definitely think that there would be one.
Okay, yeah, so it would not be
like it's not I think that's part of the whole application process. And I think Will sort of, or I don't know if it was Will or someone in the comments who mentioned it, but oh no, maybe it was you. You were asking what would be the criteria by which we select, and I think absolutely part of it should be some way to demonstrate commitment, because you are asking, people to, like, we're talking about 3 mentors taking a dedicated block for 2 months. That's a commitment on their part, and I think it has to be met by a commitment on the other side also, or it's not worth the energy. Which is part of my goal for this program too. That, speaking as someone who loves to mentor people, and I do, but there is a thing that happens sometimes where, like, you invest a lot of energy in teaching someone how something works, and then for perfectly understandable reasons, they get a new job and they don't have time to work on the compiler or something, and it's kind of like, okay, well, that's, I'm not upset, but it is a lot of work that I would love to see leading upwards. So if we can kind of pair it with at least an expectation, reasonable, no ironclad commitments, but clear expectations of how much time people put in so that they really get the most out of it, I think that would be good.
Perfect. So yeah, I think we're good to end the question session here. And so I'll just grab the slides back for a second here just to finish up. And so as I mentioned earlier, the theme for May, we haven't decided yet. We do have a couple candidates that I will mention though. So I know one possible theme was global, and another one was having to do with embedded systems. And so I think there's definitely some exciting topics on both of these. And so if you have interest in either, or you can think of any talks relative to these topics, feel free to reach out and make issues for them. For the next meeting in May, it will be on the 16th, which is nice and early in the month. I think it's the earliest one we've had in quite a while. And so it'll be running at 3 p.m. US Eastern Standard Time. And so accessible mostly to North America and Europe. And then I guess if you live in Sydney and you wake up nice and early, maybe it's for you. We'll see. But yeah, we'll end off the meeting here. So we'll do the social hour for anybody who can stick around. And thank you so much to all our speakers, and we'll see you next time.